All right. Hi, thanks for tuning in. My name is Melissa O'Sullivan, and I'm an engineer on the SnapKit team at Snapchat. Today, I'm going to tell the StoryKit story, or how we took the Snapchat embedded player and rebuilt it as an SDK. Here's the agenda for this session. I'll give a quick overview of the Snapchat story player and the origins of StoryKit. Then I'll describe how we build StoryKit, both how we handle rendering snaps and navigating through snaps in a story. And in the last section, I'll explain some lessons I've learned while building StoryKit. First, I'll go over some goals to keep in mind while building an SDK. Then for API design and dependency selection, I will explain a couple of pitfalls I encountered with StoryKit and what you can do to avoid similar struggles. So first, I want to introduce SnapKit for those of you that aren't familiar with it. So SnapKit is Snapchat's developer toolkit. On SnapKit, it's our mission to help share Snapchat's best features with other apps. And the main way we do this is with our collection of kits. Each kit is an SDK that provides a Snapchat feature integration. So when we launched in the summer of 2018, we started with Login Kit, Creative Kit, and Bitmoji Kit. And as you can see, we've added quite a few more since. StoryKit is one of the larger and more technically complex kits that we offer. So that's why I chose to talk about it here today. So let's look at some background for what StoryKit is. So this is the Snapchat story player. Hopefully you're already familiar with it, but just in case you're not, this is a story as viewed in Snapchat. And to give a little bit of background, a story is a chronological list of snaps, and a snap can be a video or an image with duration. The Snap camera offers a variety of creative tools that you can add to snaps to enhance creativity, such as lenses, stickers, and drawings. And so stories allow you to use the Snapchat camera to share what's going on in the world around you. And stories are an essential part of Snapchat. As I mentioned, on the SnapKit team, our mission is to share Snapchat's best features with other apps. So we wanted to do this with stories. We wanted to bring Snapchat stories into other apps. So we came up with app stories. An app story is created with the Snapchat camera. So an app story snap can use lenses, stickers, captions, filters, and drawings, just like a normal snap. But an app story snap is viewed in another app. So this is where StoryKit comes in. For StoryKit, we needed to create a story player SDK that apps could use to play stories, just like the player in Snapchat. So this led to a few questions on how to do this. And the biggest question was whether we could use what we already had, or if we needed to rewrite the player from scratch. In the Snapchat app, as I showed you, we have a story player, but would it be feasible to take this existing player and package it and publish it as a standalone SDK? We weren't so sure. And to answer the question, we compared the features in the existing Snapchat player to the features we wanted in the SDK. There were some large differences. First, the Snapchat story player has a lot of functionality, definitely more than we would want in an SDK. And second, the Snapchat story player relies on shared Snapchat infrastructure for downloading and caching media. And so we'd probably have to package this in the SDK as well, and this would make the SDK even larger. So we decided to rewrite from scratch. All right, so now let's talk about building StoryKit. And first, we should look at what is required, or what does this story player SDK need to do? So the player needs to be able to play snaps, to load snaps, communicate progress to the host app, and move between snaps via auto progression or user navigation. I decided to start with the to play a snap requirement. And when I say play a snap, I really mean to download, cache, decrypt, and render a snap on screen. Thankfully, others have already built SDKs for media management, but these SDKs are either for images or videos, not snaps, which can be either. So we chose two of these libraries, ExoPlayer for videos and Picasso for images, and implemented a video view controller and an image view controller. These extend an abstract class, media view controller, so that we can abstract away the media implementation details and the underlying libraries when playing a snap. This is the model that we use to describe the snap page. So it includes the content type, which we use to determine what media view controller should be used to render the snap, the media snap ID to uniquely identify a snap in a playlist, a URL to load the media, and decryption information if the media is encrypted. So I wanted to give more explicit details on how we use these libraries, and I found ExoPlayer to be really easy to work with. So I'm going to show you how we use ExoPlayer. The requirements that we needed were disk caching, progressive download, and encrypted content support. Disk caching we wanted because we offer a preloading API with StoryKit. And progressive download we wanted to reduce user-observed latency when content wasn't able to be preloaded. And we want to play encrypted content because in StoryKit, snaps are encrypted. So I want to share some code examples of how StoryKit does these things with ExoPlayer. One piece of info that will be helpful for the next few slides is that in ExoPlayer, a media source is an abstraction that specifies both the content and how it should be loaded. So the pipeline of media loading is specified in the media source. This slide shows how a media source that supports progressive download can be created from a URL. Progressive download is where a video can start playing before the entire video has been downloaded. Playback can begin with just a fraction of the video. This lets the rest of the video load while the user is watching the already downloaded portion. So progressive download is especially helpful for longer videos. So the player itself in ExoPlayer takes a media source. And as I mentioned, this media source includes both the content URL and how it should be loaded. In this example, I create the default data source factory, which is responsible for fetching content from a network. Then the method getMediaSourceForSnap returns a progressive media source created with the default data source factory and the URL. A media source created with this method would be progressively downloaded. This example shows how we can add disk caching to the media pipeline. First, to do this, we create an ExoPlayer cache instance. Then we create a cache data source factory using the ExoPlayer cache and the default data source factory. Now, getMediaSourceForSnap creates a progressive media source that looks for the content in the disk cache using the cache data source factory, then retrieves the content from network if necessary using the default data source factory. So a media source returned from this version of getMediaSourceForSnap is set up to use the cache and progressive download. Finally, we add the decryption layer. In this example, getMediaSourceForSnap has an additional parameter, decryptor, which contains decryption metadata. In getMediaSourceForSnap, if a decryptor is included, the appropriate decrypting data source factory will be added to the chain. The media source returned will retrieve the content from the cache if available, or the network otherwise, decrypt the content, and progressively play it. This slide highlights two ways that ExoPlayer is really flexible. First, data source chaining. In this example, we would have the content encrypted on disk, which is what we want for StoryKit, But if you wanted content to be decrypted before being cached to disk, you could have the cache data source factory pull from the decrypting data source factory. And second, the CBC decrypting data source factory you see here is a custom implementation of ExoPlayer's data source factory interface. It's really easy to add a custom data source to transform media in any way you want, like we do for decryption. So this slide shows how we've implemented media download, caching, and decryption for videos and StoryKit with ExoPlayer. So now let's look at how the rest of a snap is played. Here we'll look at how media rendering fits in with supporting components to create a snap page. So here we have a media view controller. The media view controller responds to a page lifecycle interface to load and start playback with methods prepare for when the page should be ready to be on screen, start for when the page is on screen, pause for when the page is taken off screen but should be ready to go back on screen, and release for when the page resources are no longer needed. So when prepare is called, the media view controller starts loading the snap into view. But even though we call prepare before we call start, which puts the snap on screen, the snap isn't always going to be ready to play as soon as its media view controller is visible. It could still be loading, or it could have failed to load. For these cases, we need supporting views that are aware of the page's media state. So the media view controller publishes media state updates. And these are those states. So let's look at these states in more detail. We have unprepared, which is the start state of all media. Preparing, this is once we start loading media into view. Error, for noting all error states. Ready, for when the media is ready to play but hasn't started yet. Playing, for when the media is playing. And completed, for when the media has finished playback. Playing and completed might seem like they wouldn't apply to image snaps, but they actually do because snap images have a duration associated with them. So if a snap image is loaded but not on screen, it would be preparing. And once its duration timer has started, it's playing. And then once that timer is finished, it's completed. So each snap page has a media view controller that implements the page lifecycle commands and publishes media state updates. And it also has supporting views for the error, header, and loading views that subscribe to the media state updates and also have the page lifecycle interface as well. So each snap is made up of these layers. And the layers are used to display the snap in its full state. So for example, when the media is preparing and start is called, as the pages come on screen, the loading view controller will show a loading spinner. And similarly, when the media view controller becomes ready to play, it will publish this state update and the loading view controller will hide the loading spinner. Similarly, when the page is on screen and the media is in an error state, error view controller will display an error message and a retry button. So each layer is responsible for loading and displaying its content based on the media state and the page lifecycle progress. And so with this structure, each page is self-managed. All right, so that explained how the story player manages individual snaps. Now let's look at how the player handles navigation between multiple snaps in a story. From the last section, we have this single page that responds to the page lifecycle interface on the right. In order to play multiple snaps, we add two more, one for the previous snap and one for the next snap. And together, these make up the player controller. The player controller implements the lifecycle interface itself, controls the life cycles of its pages, and orchestrates navigation between pages with this go-to-page indirection method. In a minute, I'll show how navigation works. But first, let's see how a story is represented. So we use this Snap data source to represent a Snapchat story. Essentially, it's a doubly linked list of Snap page models. It offers an API to get the first page and to get the next or previous page from a given page. So we use this to determine ordering of snaps in a story. And now back to the player controller. So first, notice how the previous and next pages are in a prepared state while the current page is in a visible state. This is like the resting position for the player. When we have one page on screen and pages in either direction that are ready to go on screen if the user taps to navigate to them. So this is how a transition works. When the player controller gets the command go to page and direction, first it will release the previous page. So this page will now have to be recreated if it's shown again. Next, it will pause the current page, leaving it in the prepared state. Then it will copy the current page to the previous page and copy the next page to the current page. Then it will start the current page, moving its state to visible. So at this point, the new page is visible to the user and hopefully playing. So now we just need to load the new next page. And to do this, the player controller will query the data source for the next page in that direction and use this page model to create a page view controller and prepare this page. So transitions to the previous page work similarly. And this structure enables a few performance optimizations. It prevents loading content twice in the case where the user taps back to a previous snap, and it allows nearby pages to start loading before they're on screen, which can decrease user-observed loading time. All right, so here is StoryKit in the app Triller. And if you would like to learn more about StoryKit, please check out kit.snapchat.com/StoryKit. And so now that I've explained how this SDK works, I want to talk about some of the lessons I learned in the process of building StoryKit and other kits. So when you build an SDK, you're building a tool for others to use. And you have an idea of how it could be used, and you might make a sample app to display the use case. But what's great about SDK development is that sometimes people will take the tool you built and use it in a super cool way that you couldn't have predicted. Maybe you thought you built something that would block rain, but it's actually used to fly. This is my favorite part of working on SnapKit, seeing SnapKit used to create cool, novel experiences. YOLO is a really good example of this with our login kit and creative kit integrations. But building something to be used by other developers can be a bit tricky. With app development, when you build something, you have a good idea of the environment it will be used in. But with SDK development, that's not the case. Your SDK could be used in a series of environments. It may not work so well in environments that you don't consider during development. There's a lot of variety to apps, and building an SDK that works well in multiple conditions is difficult. It's good to consider the developer's perspective. There's always a trade-off when a developer is deciding whether or not to introduce an SDK to an app. And so this is a list of reasons a developer might choose not to use an SDK. If its weight or use of resources doesn't outweigh the benefits of the SDK, if it's hard to use, or if it can't be used without making changes to the app structure or other dependencies. So this is related to this next list, which is what you should strive for when building an SDK. So a small size, and you want to be frugal with the network, battery, and memory usage. You want your SDK to be a good guest to the host app. It should be easy to use with a well-designed, clear API and easy setup. And lastly, compatibility with the host app is pretty critical. So look out for potential conflicts in structure and dependencies. All right, so this is an example of how we made an API that wasn't super easy for all of our partners to integrate with, and also how we fixed it. When building the StoryKit player, we had to decide what type of Android UI element to make the player. We needed some sort of UI for displaying snaps, but each of the options has different implications for the SDKs API. We had two requirements to work with. We knew that we wanted the player to be able to subscribe to Android lifecycle events when the player is active and the app is backgrounded and foregrounded. We wanted to be able to receive these Android system updates to pause and resume playback. The other requirement was that the player must be able to notify the host app of player events, like when a page is displayed, when playback starts, or when the story has finished playing and the player should be closed. Wanting to obtain lifecycle events to pause and resume the player, we considered having the Android component be an activity or a fragment. But with an activity, it would be somewhat difficult for the host app to be able to subscribe to the player events. So we decided to use a fragment. This was our StoryKit player fragment implementation. With the player as a fragment, we used this weak reference listener pattern to allow the host app to pass a listener to the player. But this pattern requires that the host app implement the StoryKit player event listener in an activity. And this is a large constraint to put on a host app, as many apps now only have one activity, including Snapchat. If an app only has one activity, it's probably quite uncomfortable for them to put an event listener there for a player. So this design was not flexible enough for different app structures. So we went back to considering options and discovered that Jetpack's lifecycle aware component is perfect for our SDK's requirements. This is the lifecycle aware component implementation. So with this, we are able to obtain lifecycle events to pause and resume the player when the app is backgrounded and foregrounded, and we can receive the listener from the host app. And we only ask that the host app pass in a reference to the lifecycle. So with this, there are no harsh constraints about how the host app uses activities or fragments, and it's much easier for partners to integrate with. Apps are built in a lot of different ways, and you want your SDK to avoid making assumptions about structure. Constraints like this listener has to be implemented by an activity should be avoided, because constraints like this could be the reason that an app decides not to use your SDK. In particular, for building modularized UI components, SDKs or not, Jetpack's lifecycle-aware components are great. They're really helpful for allowing you to avoid using fragments or activities directly and to make your code more flexible. Dependency selection is extra tricky in an SDK. Here's an example of how we made a wrong choice and corrected it. Originally, we used Glide for handling images in StoryKit. And through development, we hit a couple of roadblocks. We used Glide 4 with a custom component for decryption. This setup for custom components in Glide 4 requires that each client app has a Glide app module. So we had to instruct partners to create this in the StoryKit setup. This wasn't ideal because it made it harder for partners to get started with StoryKit. The more serious issue we ran into was that with Glide was that Glide 3 and Glide 4 don't work well together. By using Glide 4 in our SDK, we are preventing any apps that use Glide 3 and have not yet upgraded from integrating with StoryKit. We resolved this by switching to Picasso. This was a good choice also because it's much smaller, but included all of the functionality that we needed. So again, dependency selection is tricky. Obviously, you want to use as few dependencies as possible. with each dependency you introduce, it becomes more likely that apps will run into conflicts when trying to use your SDK. But there are cases where you should use a dependency, like image and video handling in StoryKit. And so if you're choosing a dependency, try to look out for these things. Try to consider if it's small enough. Obviously, as the smaller the SDK, the better for covering the functionality that you need. And if the SDK requires additional setup for the host app, you want to keep the setup for your SDK as simple as possible. And finally, if the SDK offers multiple versions that are incompatible, then by choosing one version, you could be keeping apps that use another version from being able to integrate with your SDK. So there are a lot of things to look out for when building an SDK. And the hard part is that you don't know what you don't know. So you should listen to developer feedback. We've made a lot of improvements in response to developer feedback. In my opinion, having an open communication stream with developers is really important for improving your SDK and making one that's very useful. So in conclusion, SDK development is tricky. With app development, you mostly have to consider how your decisions impact the user. But with SDK development, you also have to think about how your decisions impact the app developer in addition to the end user. So in addition to good general principles, be careful with dependency choices and API design. Maybe use Jetpack's lifecycle aware components. And most of all, listen to developer feedback. All right, so one thing to note is that we have a Snapchat panel coming up at 3:20. There will be a set of engineers, including me, who can answer any questions you have about Snap Android engineering. And if you have questions about this talk, SDKs, or SnapKit, I can answer questions now. Yeah. So the first question is, was an asynchronous framework used to develop the StoryKit SDK, coroutines, RX, etc.? So yes, we use coroutines initially, but actually we changed to RX because of a similar issue with a partner dependency conflicts. So we use coroutines and RX for the preloader functionality. So there's a preloading functionality API for StoryKit, so you can preload content to a cache before the player is even created. The second question is, what did you learn about testing? Can you share some insights? For testing in SDK is quite complicated because there are a lot of parameters to consider. In addition to the things you have to consider with an app, which are different phone types, different Android versions. There's also the possibility of the host app having a different Android version or different ProGuard rules. So it's pretty complicated. I think it's the best approach to it is probably just making a list of all of the different things that should be tested, and that's what we've done. So we have quite a long list of our release testing. Another question is, how did you handle theming? Do you allow developers to customize the look and feel of the SDK? So for this, we allow some customization. So the player can be any size. And there are a couple of options for scaling the content. Additionally, there's like muting and things like that, but we don't have theming per se because we wanted it to feel like Snapchat. And so the views, like the loading views and the error views, are all taken from Snapchat. And another question is, how do you manage ProGuard while shipping an SDK? So for this, we have some consumer ProGuard rules that are very lightweight, and we use them to ensure that our certain things that we need our SDK to not be ProGuarded so that it will run properly are there. And then we also run ProGuard on the SDK as it's created. All right. Another question is analytics for story views, engagement, and other metrics also part of SnapKit? So for story views, when you view a snap in StoryKit, there's a read receipt, so that if a user has posted a snap to their trailer story and then it was seen like 100 times, they'll see in my story management of Snapchat that the snap was seen 100 times. And so in that respect, yes, we do definitely have story views. And yeah. The next question is, do you use dependency injection in your library? So yes, we use Dagger too. We haven't had any conflicts with that yet, thankfully. And the last question is, how long did it take to rewrite the SDK from scratch? It took a while. I'd say probably like a good set of months, yeah. Well, to release a new library, I think we do a lot of testing with like a test app that does like the limits of the SDK's functionality. And then additionally, when we have been developing SDKs, sometimes we'll test them with other developers so that as we're designing the SDK, we can make sure that it's really giving the experience that we want and that like developers want to be using. So yeah, I think having a few people use the SDK before it's officially released is a really good way to ensure it's stable. And yeah. All right. Okay, maybe this time for real. Thanks, everyone.